In this lesson, we're going to be solving linear equations by using the graphical and numerical methods. When we solve linear equations, there are three ways that we can solve them: graphically using the graph, numerically using a table of values, or symbolically, which is just using algebra. So let's solve this equation. 3x minus 7 is equal to 5. Okay, so I'm finding where my left-hand side is equal to the right-hand side, and we could physically see an intersection here at the point 4, 5. So to answer my equation, the x value that gives us 5 is x equals 4. We can also solve this equation by using the graphing calculator. So what we're going to do is we're going to enter each side of our equation into y equals. Use Zoom 6 for just a standard graph. We may need to adjust this graph after we look at it, but for now we're going to start with a standard 10 by 10 graph. And then we're going to find its intersection by selecting second and then the trace key, option number 5, and then hitting enter 3 times. So here I am in y equals. I have 3x minus 7, that's my left-hand side, so that's going to go into y1. The right-hand side is going to go into y2. Zoom 6 so that we can see our standard 10 by 10 graph. Since we see an intersection, there's no need to adjust the graph because all we really need is to see that intersection there. Second trace, option number 5. We're going to try to get close to the intersection, and I'm just using my left and right arrows to do that. And once we're on the intersection, we're going to hit enter for the first curve, enter for the second curve, and enter for our guess. So that's why we wanted to scroll to get as close to that intersection as possible. We see our intersection is 4, 5, so the solution to this is x equals 4. For an equation like this, you may not want to use the graphical method. It's a pretty easy two-step equation to solve. So really, this is just a practice for some of the harder looking types of equations. Equations that have decimals or fractions or square roots in them. That's an equation that we're going to want to use the calculator for because it just makes solving the equation that much easier. So let's look at this next example. We would like to solve 4.5x minus 7.75 equals negative 5.25x plus 5.5 by using the graph. Again, I go to y equals, and I'm going to delete everything from the previous problem that we did. The left-hand side of my equation is going to go into y1. And the right-hand side of my equation is going to go into y2. Make sure when you have a negative number like we do here that you use the negative sign and not the minus sign. If you use the minus sign, you're just going to get an error. Also, I didn't show you this before, but the x key is right here next to that green alpha. Now that I have everything typed in, I double check that I was correct in what I typed. Zoom 6. Let's see if we can see the intersection with the standard graph. And I do. I see my intersection right here. Second trace, option number 5. Again, I want to scroll to get close to that intersection so that the calculator approximates it correctly. I see that I have an intersection here at 1.3589744 and negative 1.634615. Now remember, we're solving here a linear equation, one variable. We're only looking for the x value. I didn't say on here what to round to, so I'm going to type out this entire number. When you're not given the direction to round, then you want to use the entire number. Also, if you need to show any work for this type of problem, you would just sketch your graph. It doesn't have to be perfect, but it should be pretty accurate to what you see on the calculator. Let's try one more with using the graphical method, this time with fractions. So here we have 1/3 x minus 7/9 is equal to negative 5/3 x plus the square root of 2. So we have several things going on here. We have negative numbers, we have fractions, and we have a square root. Again, this is not something that you would want to solve using a symbolic or algebraic method. It's much easier to use the graph. When you're typing in fractions, you want to be sure to put your fractions in parentheses because these graphing calculators don't have a dedicated fraction button. So 1/3, I would type in exactly like this so that your calculator reads it as 1/3, not 1/3x with the x in the denominator. Again, 7/9 in a set of parentheses. Here, it doesn't matter if you put the negative sign on the inside or the outside of the parentheses. I always tend to put it outside, but that doesn't make a difference. And then your square root key is just second, and then you see it right here in the light blue. Zoom 6. Let's see if we see an intersection, which we do. If we didn't see an intersection, we have a couple options. We can zoom in or out, which say I wanted to zoom in, I would hit option 2, and then you have to hit enter in order to zoom in. So this gives us a little bit nicer view of our intersection. The other way that you can change what you're seeing in your viewing screen is by using window, which we'll use in later videos, especially when we talk about applications. We'll use this window key a little bit more. Second trace, option number 5, let's find this intersection. Enter 3 times. And again, nothing told me to round, so I'm going to write the whole number out. So x is equal to 1.0959957. In the next example, we're going to use our table. And what's nice is that the instructions really don't change all that much. We start off the same way. We plug in the left-hand side into y1 and the right-hand side into y2. So we're going to try again a very easy example, and then we'll move on to something a little bit more difficult. So 4x plus 6 will go into the left-hand side. So that's y1, 40 is y2. We're going to hit second, and then if we hit the graph key in light blue, we see we're going to look at the table. And we're looking for where the y1 values, which is my 4x plus 6 values, is equal to the y2 value, which is 40. Okay, so I see that 40 would occur somewhere between 8 and 9. So what we need to do is change the way that our x values are being counted. If you look at our x values, they're just going up by ones, but we could have them go up by halves, by tenths, by quarters, whatever we want. So second, and then the window key brings us to this table setup. So I know that that output of 40 is going to be between 8 and 9. So I'm going to start my table at 8, and let's just count by quarters. And if we need to, we can make that number higher or lower. Okay, by rewriting our table, we notice that at 8.5, y1 is equal to y2, and x is equal to 8.5. In order to show your work for this type of a problem, you would just write down a couple of rows of your table, usually the row above, the row including your answer, and the row below, in all 3 columns. So your work for this type of question would look something like this. You would just need the 3 rows. In our last example, we're going to solve negative 0.5x minus 2.75 equals 1.5x plus 3.25 using the table. So my left-hand side is negative 0.5x minus 2.75. y2 is the right-hand side of my equation, which is 1.5x plus 3.25. Second, and then the table, and we're looking again where y1 is equal to y2. So I look at my y1 values, I have a lot of negative values. My y2 values, they're all positive. If I go up, I noticed that both sets of numbers are getting closer to 0, just in opposite directions. You may want to rewrite your table so that it's counting by ones again. It's not necessary, but I'm going to start it at 0 and count by ones so that I don't have to scroll for too long. Okay, and I see my answer right here. When x is equal to -3, y1 and y2 are both equal to 1.25. So my answer here is x equals -3.